My name is Francisco Paco Estevez, and this is Revisiting Types in Kotlin. So, this is kind of a prescriptive talk, and I'm going to be talking about something that maybe you have heard before about types and about the way that you use types to help you in development. Because of that, I always say like this is a eat your veggies kind of talk. Like there's a lot of people that already eat healthy, and there's a lot of people that just like, yeah, I'll do it at some point, you know, but I'm not ready yet. So this is kind of an introduction on how to take that little step. So let's just start from where we know we're at. So classic object-oriented programming tells you that classes encapsulate both data and behavior. They are some kind of like internal machine, state machine, closed system where the methods are designed to interact with the fields in a way that mutates the model and you know, things happen. So let's just deconstruct this statement a little bit and check the both parts. The first one is the data. So when you're trying to represent data in Java, you have a series of challenges because your classes have to adhere to some certain standards, namely the beans standard. You have the possibility of having no fields, non-no fields, any kind of constructor, so empty constructor with all the values and everything. So you have to like create these huge DTO classes if you want to get anything going. On the other side, you have the immutability problem in the sense that as we're moving towards a more multi-threaded kind of paradigm, if you have models that are mutable and they are shared among threads, you have cases where the state is inconsistent. So we have to think about those. We also have nullabilities and validations. So this is part of Java. Everything can be null, and values can be not part of what your domain is expecting from them. So you can have empty string, you have misconstructed strings, or any numbers that are not within the expected range. And lastly, and this is just a JVM kind of problem, is the equals hash code and toString. If you want to do a structural equality, meaning that you compare all the fields rather than the instance, you have to override the method, and you also have to provide a toString so the printing is a little bit better than the original one. The second part is the behavior. So basically, how do you structure your code or your application, your program, your backend server in a way that is meaningful? And in this regard, like, here be monsters. We have a series of like guidelines, talks and classes and like workshops and everything about how you structure your code and how you make things work in a way that makes sense to you, makes sense within your paradigm, or stays within the kind of expected things. So knowing all of this, what is a type anyway? Somebody at the back, like, just ask, like, what is a type? So a type is a finite set of encapsulated operations. It defines a representation of either a value or a behavior associated with values. Sometimes can be represented with classes, and some need some kind of language support. We'll go a little bit in depth with this in a moment. And the most important part for me is that they can be checked at compile time. So you make the compiler work for you in this sense. You're providing something that is called a proof, that you know this is the available behavior for this specific type, and there's no other. And you have to comply with that. And please remember this, because this is like the cornerstone. So moving back into Kotlin, what are the types available in Kotlin? The first type are the primitives. Nothing really special about them, really. The good bits is that they don't have type coercion. Like, everything is not implicit, so you cannot do the sum of like an integer and a float, or you cannot do division between two integers or integer and a float in a way that you have an unexpected behavior. So you have the usual case where you're just trying to like divide two integers, and then you were expecting a float, but you actually get an integer, and you have to be explicit about it in Kotlin. The second good thing is that there is no distinction between base types and wrap types. So everything happens behind the scenes for you. You only use one single type, which will be int or float or boolean for your cases. The second type that I want to talk about is functions. So basically, functions become runtime objects. They become top-level constructs. They have first-class support in Kotlin. You can have a function class that is just like a value or a variable that you're sending around your application. You can create instances of every function or every method using the operator colon. So basically, let's say you have your class, I don't know, user manager, and user manager has a get, and you want to use that get somewhere else as a parameter. You use the colon to create an instance. You can define them using lambda nomenclature, and we'll go in the examples about this. Basically, what you say is, this is the parameters that I'm receiving, this is the type of the parameters, and this is the expected type of the response. And lastly, if a function takes another function as the last parameter, Kotlin offers you some kind of syntactic sugar that works great for DSLs, that revolves around there's no need for you to add parentheses, or there's no need for you to have any kind of like special block. Moving on, the next type, and this is one of those that can be represented with a class, is the collections and combinators. So they have any kind of list types, array types, map, sets, and basically what they did is some kind of re-implementation on top of the original Java classes. And they are interoperable, they are completely compatible, and they're just easier to work with because they do exactly what you expect from them. They just put a lot of like thought onto them. It comes in two flavors. It comes on mutable collections and immutable collections. Traditionally, in Java, when you use an immutable collection, what it happens is when you call one of the methods, you will get an exception. So everybody will just, everybody has done like arrays dot to list, and then what happened is like, oh, I tried to append at the end of the list, and exception. So we don't want that to happen. So we have two separate interfaces for mutable list and immutable lists. And lastly, the operations come with what Java 8 added as a stream API. So basically, you're able to have support for operations on sequences like map or filter or reduce. There's a whole lot of them, and I recommend you just go to the link and have a good look, because it's really extensive, and it could have like multiple talks just on that. So. Show, don't tell. So I told you before we were going to be exploring a little bit what we're doing. So basically, we have a variable that is our immutable collection. And you can create it simply by using list of. And you have a list of elements, and it just kind of works for you. The good part is, if you try to go to immutable collection, and then you say add is not a valid operation. You have another operation if you want to create a new one, which is plus. And what plus does is it creates a new instance of a list with that element appended at the end. And you say, okay, but it's copying the whole list, and maybe it's inexpensive. And there are several implementations for that pattern that are being explored right now by the Kotlin community. I think they have one where they are using arrays behind the scenes, and they want to change it to types like the ones used in Clojure. But it's still experimental. The second thing that we talk about is that immutable collections have operation on them like map or filter. And the definition for map, I have it here on the top, and basically says you're taking a parameter which is a function type, and the function type goes from any type T to any type R. So basically, you're passing a function that transforms from one to the other. So what you have to do is collections.map, and then in here, you pass a function. And the function will have a lambda. So let's say we have a value, and this returns value plus 1. So with here, what you get back, again, is another new list with those elements changed because the operation hasn't happened. And we can also filter on them. And this is the syntactic sugar I was talking about. So if you see filter, the value is exactly the same, except it takes the current type and is supposed to return a Boolean. So instead of having value, and then just say value lower than 2, what you want in here is what Kotlin gives you, the syntactic sugar, is that you don't need the parentheses because it's the last value inside the element. So that's actually really neat for kind of DSLs. And whenever you're using some kind of advanced Kotlin libraries, like Anko maybe, you will see that they use this pattern a lot. Lastly, if we say 3f, for example, that means that the original collection is not a collection of integers anymore. It's a collection of numbers, both float and integer. And you cannot do the sum operation. So it's telling me, hey, there's an error happening in here. So what you have to do is be specific about your types, and you say value.to. You can say first, map every value to int value. It's not doing the casting. Anyway, that's the whole idea. So basically, you can have pass functions as parameters, you can have your collections, and you can also have your mutable collections, which are created using simply the word mutable in front of it. And when you use a mutable list, you can just say add, and the add happens in place. It doesn't create a new list. It just works the same way you would expect from an existing array list. So let's go back. Cool. So the next bit, we're getting introduced right now into classes. So what we want to do with classes is that Kotlin provides several different types, and each one of them has their own special properties. So the first one that I want to talk about are data classes. And these data classes are a way of defining your POJOs, your DTOs, any kind of object that is simple and that is supposed to be fulfilling the Vins spec. So what it gives to you is that you're able to pass any number of values into the constructor, any number of parameters, and those parameters become the fields inside the class. So you have to define two types of fields, which is val for immutable, which means that the value can only be set once, and bar for mutable values. Secondly, because of the type system in Kotlin, there's a difference between nullable types and non-nullable types. So every type that has a question mark at the end is defined as a nullable. So it can be both null and non-null. If you're using a non-nullable type, any regular type without a question mark at the end, if you're interrupting with Java, Kotlin inserts a precondition with a null check for you. So if you look at the code from the Java perspective or the generated code, you will see that precondition is in there, and you're going to get a compile time error. But also because if you have the linter on, you're going to get a notification that this method is annotated with non-null, and you're still calling with it. So if you use lint as a way of finding some kind of errors on compilation, that would sort it for you. The other one that is really great is name parameters. So if you're providing default values for each one of your elements in your data class, and each one of you can create a new instance with only one or several of those values changed, and you can just name the name of the parameter, and that's the only one that is going to be modified. So let's say, for example, that you have a class that has name, age, location, and everything. You can create a new instance, and the new instance may only have the location and the name and nothing else. So you have a constructor pattern built into your object directly. Lastly, you get, if you add the data qualifier in front of your class definition, you get all of the things above, plus valid implementation of like equals, hash code, and toString. So basically, what used to be a long, like really had generated Java class becomes one line definition. The second type is any kind of open classes and interfaces. And basically, it's just Javaland. Like literally everything that you can do in Java 7 or Java 8 or Java 6, you can do in Kotlin. You can translate your code one-to-one, and 99% of the time it's just going to work. The only difference are related to generic types, row types, and things that are like a little bit too out of scope. But yeah, in general, everything that you expect from Java, you can expect from Kotlin. Next type is enums. So, counted types. And enum classes in Kotlin basically are the same as in Java. You just define an enum, you define each one of the values that are in there, each one gets assigned a position, and you can also access it, each one of the elements through reflection. So you can just say, hey, I wanna get all the elements that are available in this enumeration at runtime, and you can just iterate through them. So it implements the enum type, same as it does in Java, and you can just like generify around them. That's really neat for that. And lastly, and this is basically the reason for this talk, is the new type that is not available in Java, and is the one that gives you the most change from the way that you're defining your behavior inside your app. And those are called seal classes. Seal classes is not a new concept, it's something that already exists in other languages. You may have heard calling them union types, algebraic data types, tag unions. The only variation is like the implementation for them. So what you do with Java with seal classes is that you're trying to have what is called the domain-driven design. You're trying to define your execution in a context that is checked by your compiler. So what you do is you separate your data from your behavior. Already with the data classes, you already have an entry point saying, hey, this class is only data. There's absolutely nothing else. We're just going to be working with that kind of information. You have to express your execution flows as data. So instead of having your application defining a state as, oh, this application is in this state if I call this method, or if I go to this part of the app, what you have is something similar to like strategy pattern or the other one. Anyway, policy pattern, where you define your execution depending on the type that you're referring to. The next one is that you encode your behavior in those types. So you define how your application flows depending on those wrapping types for the data classes. This is one of the greatest parts, is like you want to make illegal states unrepresentable. Because you have data now instead of method calls, you have to find a way of matching whatever validation that you have to a different state. And lastly, you want to push the validation to the edges. So you have a whole application that is network connected, that has database, that has I/O, and those are your failure points. Your failure points are not in your logic. Your logic may have defects in the sense that you have encoded the wrong behavior, and that's fine. You have tests for that, you have a compiler, but the kind of problem that you have with exceptions, with like nulls, and all those checks that happen can be pushed aside. And you have this little island of like immutability behavior and everything that is good and nice about like domain. And it works. It just works, and it's beautiful. So show and tell, again. So basically, what I wanted to show you is, here at the beginning, we have defined a data class. So the data class is only a qualifier at the beginning. And then you have to define in the constructor all the possible fields that you have. And fields can be defined simply by using val and var. Because this is some kind of like domain class, we want to have it as immutable. So I'm going to pass any parameter that I have as val. If you have you see the type. The type is a string, which means that it has to be provided. It cannot be a null. And this is going to be checked for you. And lastly, we're providing a default value, which is simply an empty string. This other data class example is a little bit different. It's a DTO, it's a data transfer object, which means it has to support the beans spec, because we want to have like serialization, deserialization, we want to go to network with it. It doesn't really matter, it's outside of our domain. And this type requires the same kind of ID, but this ID can be a null. It can be nullable. And it also is provided with a default value of like empty string, but let's remove that for now. So how do you use to define the strategy pattern, the policy pattern in Java? It's an open inheritance. So basically you created an interface, or you created an abstract base class, and you say, hey, this is all the possible elements or possible methods that are required for my class to work. And you went there and you inherited from it, and you implemented that interface. The problem was there could be any number of classes that inherit from there. So even if you make the scope into package or any kind of like local scope, people could come, duplicate that scope, and continue with the inheritance, with more elements. If your inheritance is closed, it means that you know how many possible inheritors are for one single type, which means that at compile time, it can tell you whenever you're using some kind of matching or switch, it tells you haven't handled all possible types. We warn you because we know this is a seal class. We're going to tell you this is all the possible states, and you have to handle each one of them. So close inheritance. The idea is that we're defining something within our domain. And the example that I'm going to be using today, what it does is it creates some kind of user input. With the user input, it just goes to the network. The network returns a value. We validate that value, and we present it on the screen. So, get a value from network, validate it, present it on the screen. So what we want to do is like represent all possible states inside that screen. So we're going to say, okay, my current states inside my seal class are idle, which means there's no network request right now, there's nothing happening, this is my initial state. We can have loading state, which means I've gone to network, I'm waiting for things to happen, there's a % of loading. We have a success, which means the network returned some value that is valid for you, and you have an error. And the error is just like some kind of problem that happened with the application. So you tag each one of the classes, each one of the inherited elements with the data that is relevant for you. So the seal class defines all your view states, but each one of the classes contains the information necessary to represent each one of those states. So the next part is how do you encode your behavior in types? So because we have seal classes, I have defined an interface, and the interface is called and then. Basically, if you've used any kind of JavaScript or you know what a promise is, this is basically the most simple implementation for it. So the idea is that you're providing a function that takes the current type, the current value, and returns another wrap type for a different one. So let's say we're going to define another seal class, which is a result, and this is a result from the network. And a result from the network can come back with 3 values. Success with a value, and you get the result. A regular success with no data associated, so you don't know exactly what happened, it just returned like 200, and a failure. And the failure, it comes with the exception. And this is the result that you get from like your services layer. So what you said is, okay, so this class result implements and then for itself, meaning that it's capable of chaining with itself or with any type that is valid. So the only definition for and then is that you pass the current function that is passed to you as a parameter, and you invoke it with our current instance. This may be clear in a second. And then the other function is value, and value, what it does is just exits the and then chain, and it returns back to the original class. So the other part that I was talking about is like you want to move the validation to the edges. So let's say you return a user from the network, and you have your DTO, and then you have to introduce that into your domain. And what happens if there's a failure? As we said, we're trying to model state as data. So the data has to be able to define what is a valid user and what is an invalid user. And if you have some valid user, it's going to return you the model that is within your domain, the user info, the one that contains immutable values, the one that is like the way you want it to work. And if it's an invalid user, it just tells you this is just what the network returned, and I don't know what happened with it, so you can just go and like print it on the screen or do whatever you want with it. So let's put everything together. So we have the class tests. I have a simple test, and what I do is I do an action, and this action returns a result from the network, and then I validate the result from the network, and then I transform it into one of the possible UI states, the correct error ones, idle, and everything. And finally, I exit the chain by using value. If you see, I get helping here, and it's telling me that I can convert it to a lambda reference. If you remember before, we said that the colon operator, it was the other way of defining a function. So basically, in this function, I'm passing it, and it in here is the parameter. If you have no parameters, you also have the possibility of using it, and it represents a single parameter inside your function. Because the static analyzer recognizes that you're just forwarding it to a function, it tells you that you can convert it to simply passing validate. And validate is a runtime object, which is a function that takes a t and returns a u, and this u has to implement and then. So you're able to chain them together. So basically what we have is do an action which goes to a network, and in this case we're going to result with a success with a value. And the value is going to be a user info DTO with my name. When we want to do the validation, what we do is we're going to receive a result, and we're going to be returning a user in the business layer. So we already know that everything is in our domain. So the way of the referencing CO classes is by using the function when. And when is is a function that is defined at top level, and it takes the reference to the current value, and it takes also a function with the block with the possible results. So it's similar to a switch, but it's overloaded to be able to accept instance of checks or like numerical checks, any kind of Boolean that you do. If you would use this in Java, basically you would have to write a layer of nested ifs. And basically, that's what they are doing behind the scenes for you. So what it does is like, when value, if value is result, then this, if value else is result success, else if value is failure, it does the next thing. So the definition is, and you pass the type. So you say, if the value is of this type, similar to instance of, then you execute this block. And in this block, what we're doing is like checking that the username is not null. So that's our validation for this case. So if you remember, user info DTO could be null. And we don't want null values inside our domain, so we're going to say this is an invalid user. So if ID is null, I'm going to return a valid user. If my user is not null, or if, sorry, my user is not null, then I'm going to return a valid user. If my user is not null, then I return an invalid. And if the result is a success, but I still don't have a user, I'm going to present it with invalid user with an info DTO that is empty, because I don't know what happened with it. And if the result is a failure, the failure is also going to be converted into a valid user. So it makes this function input-output. You have one input, you have two possible outputs, and you can do the testing for it because it's pure and it's really simple. The next one is to UI state. And to UI state does exactly the same when, except it takes a valid user in business layer, and it converts it into a valid UI state, which in this case would be success or error, depending on the type that you want. And finally, I have a helper method, which is print value, and print value only returns like a string representation of your thing. So let's say for 1 second, let's run this test. And the result is basically telling me that we have a user info that is called Paco. And the user info is received because at the endpoint, we have received a success, and we have the information about the user. But if I had a failure in here, and I say this is a runtime exception, and it's an error, it's an explosion. It's going to tell me that there's an invalid user. And this is within our domain, but it's a little bit off. It's like not exactly what we wanted. So why is the user invalid? What happened with it? So instead of this, we're going to add a new value to the possible user states. And we're going to say we have valid user, invalid user, and absent user. OK. So I have the class absent user. I run the tests. And it says, hey, the when expression must be exhaustive. So you have to add is absent user. You have a new possible state for your application that you haven't provisioned for. And this is going to fail all the way through your application. Your compiler is telling you what your problems are. So what you can do, you have a simple thing, add remaining branches, and then you provision for it. So if we get an absent user, what we get is like view state. We have an error, and it's like network failed. So we run it again. Oh, it's still invalid user. What happened? Isn't this model like, isn't the compiler checking for everything? Yes, it does, but it doesn't check that you haven't committed any kind of mistakes. So basically, we're still returning user in business layer, we're still returning an invalid user, and what we want is an absent user. Huh?
It's success, not failure. So we should I think it should.
Oh, sorry. No. Absent is both an error and a success, because if you get a success with no data, it's still some kind of network error. It's domain modeling. You can add a new state. You can add a new state that's saying the user was not received correctly. You can model the state any way you want, and you still have one function that takes one possible input and many possible outputs, and you can run the test cases for those. So you have to still provision your test cases to make sure that your application is behaving correctly. So we run this again, if I remember what keys it was, and then we said the network failed. So it's able to forward all the information about your domain simply by using this data information. And you're just defining the way your data is being sent around by encoding the behavior, in this case, the and then, within your types. Let's go to the end of it. So seal classes in Kotlin. We're talking about close inheritances. So that means that the compiler is able to provide you with assurance that it knows how many things you can do with it. Accessing the fields and methods. So once you do the when, in the next block that you have with the is check, the reference is already casted for you into the value. I made a mistake. I didn't show this. I can show it in a second. I'm gonna make it larger now. So when you receive the view state, in the end, success is the only one that contains the user information. So basically, by the time you reach here, it's already smart. I'm sorry for the people on the back, but it says smart cast to view state.success, which means that it's already casted for you, and you are able to access all the fields in a meaningful way. Let's get the pointer back. Yes. OK. So you use when, you use is, and the compiler checks that all cases are handled for you. The next part is that inside seal classes, each one of the internal elements can be a data class if you want it to represent as pure data, and they can also implement interfaces. But that only happens on Kotlin starting on 1.1. And lastly, and I think I'm the only one that is excited about this, you have type alias. So if you remember a second ago, we had the and then kind of chainable type. It was a wrapper. And at some point, it can become and then of a list, of a map, of a pair, of whatever domain object that you have. And type aliases, what it does, it provides you a way of defining a single name for that composition of elements. So if you're in plain Java, you may have some signatures, like function signatures or everything that are super long. And in Kotlin, you just get like one line. This is my network request, and my network request is actually a function that takes a CO class, and it returns an observable of a pair, of a tuple, of a val, of the other CO class, and it just gets reduced to a single element. So really cool. So yeah, so my advice is just like make the compiler work for you. Right now, when we do things in Java, the compiler is just something that you do at the end. It's like, oh yeah, I made that, like this small mistake, or types again, you know, like, oh, this class is not correct, but that's fine. But in this case, what you're doing is like making the compiler tell you where you have changed things. And usually you do this by testing. And testing only can cover so many cases. And in this case, those cases are already proven for you at compile time. So I think that's all. What happens if I can't use Kotlin? Basically, this is a construct provided by the language, but there's a way of encoding it in regular Java. And I went and did that based on the Scala version. So if you're using Java 8, I have Java sealed unions. If you have Java 6 or 7, you have sealed unions. And if you're in Scala, you should be here because you know more than anybody in the room. But that's fine. So yeah, that's my blog. I talk a lot about like basically reactive programming, but I'm going to try to do a little bit of domain design, Twitter, GitHub, and you can find the slides for these presentations at the tiny URL at the end. So I think that's all.
That's a good thing because it's super interesting. But let's start something that's probably more interesting for you to answer. So you defined an end-then, which is basically a generic interface that needs to be applied, which allows your types to be chained
Yes.
to all those actions. Now, is this something that you feel like you came up with yourself? Like it's something you personally do, and it's not really bound to the sealed classes, or is it something you see arise when using sealed classes all the time?
Yes. So it's a functional construct. I didn't come up with it. It's very old. So whenever you're using reactive extensions or you're using any kind of functional, that's flat map. That's basically flat map. So that's the way of defining a generic wrapper for any type that you want for any of the sealed classes. And when you have multiple sealed classes definition through the app, that's one way of changing from one to another.
Yeah, that's exactly what I was going to ask as the follow-ups, like how does this then relate to reactive programming, where you would already basically have a stream of this data, and you can already apply functions, and you can lift and apply different operators that you would write yourself. So why would you still need to implement an end-then interface?
Yeah. So when you're using an observable, you're still passing data inside, and the observable does not have a bound elements inside. So what you would have is that you have the observable of the seal class being passed around, and then you do flat map of the observable, and then you do the when, and in the when block, you return the next observable. So you're still defining your behavior within that model. So it's giving you a possibility of exiting the when construct depending on each one of the states with a new observable. So you're defining how your behavior flows based on that. When you're dereferencing at the end, observables are only a way of dispatching the data. But the data still has to be used and has to be the reference and has to be found out what case are we in or what state are we in. So, and then it's another way of dispatching information. It's just that. It's just a tool.
Okay, somebody else.
Yeah. Anyone else? No. All right. Thank you very much.